Hey guys, welcome back to Maths Cube. Today we are attempting the second part of the 7th question from the International Advanced Level Mechanics M1. So without further ado, let's get started. We have to find the C and the D part in this question, and to find the C part, which is find the value of t, we have to go back and look at the diagram we drew on the second part or the B part. There you go guys, this was our graph. Previously we drew in the B part. Now what we'll do is we can to find the value of t, what we can do is we can look at the formula, which is a very prominent formula, which is speed equal to, sorry for the equal sign there, speed equal to d upon t. We know our speed and we have to find the t. We also know our d, which is in this part they mentioned it. I'll just let you know. There you go. While he is deaccelerating, he falls a distance of 73.75 meters, and that's the total distance till the 20-second mark. So what we'll do is we'll go about this way. We'll multiply the t with the speed and then we'll set it equal to d, which is our 73.75 meters. Or what you can do is you can use this formula too, which is a very easy and handy equation, which is Suet equation, s equal to vt, because we don't have our u, that's vt minus, if it was ut that would be plus, and that's vt minus half a, there you go, that's our acceleration, t squared. We have our t's in there, we have our a also, which was 3.9 meter per second, and we have our s. So why don't we plug our values in? There you go, 73.75 is equal to 24.5 t minus half into 3.9 t square. Now what I'll do is I'll just simplify half into 3.9. We can see that this Suet equation is taking a form of quadratic function. So to make it look like a quadratic function, we can do is 73.75 can be made to shift that side, which will go negative, and we can set this equation to 0 or equal to 0. There you go, minus 73.75 plus 24.5 t minus 1.95 t squared, and that's equal to 0. Now what I'll do is I'll just bring my calculator up and just plug these values into the equation. Just go about the mode setting, the fifth one, which is the equation one, the third one, that's for the quadratic, and just plug in the values. A will be minus 1.95 t squared, that's the second polynomial. Always remember a is the second polynomial. That's, and remember the signs too, that's negative 1.95, and then we have 24.5, that's positive, and then we have minus 73.75, and just plug it in here and just press the equal sign again, and there you go. Our first value will be for the t, that's 7.56. Always remember guys, they said that the t or when they say that his parachute then opens and causes him to immediately deaccelerate at a constant rate of 3.9 meter per second, that was the acceleration. The t second will be less than 6, it can't be greater than 6, so we will ignore this value and we'll go about the next value and press equal, and there you go, that's 5. So our t value, you can say our t value is equal to, sorry about the equal sign there, you go, our t is equal to 5 seconds, and that's our C part done. 5 marks easily gained. Now moving on to the D part. So the D part is find to the nearest meter the height of the point H above the ground. So to find the H, or you can say the height above the ground, we know that the height in the speed time graph is under the graph, and I already mentioned these lines. You can see I have a triangle, a trapezium like graph, and a rectangular graph. We also have the distance of 73.75, which will be added, of course, that's the distance until it hits the ground. So what I'll do is I'll just find this area first, the triangle, and to find the distance of the triangle, the formula is half into bh, or b you can just take 2.5, that's the time, and h is the height, or you can say 24.5. plugging in the values. There you go, half into 24.5 into 2.5, that gives us 30.625, and then we can add 73.75 to that. And now coming back to the last part, you can say the rectangle and the trapezium one. To solve this one, or to find the height within finding the v here, will be difficult because we don't know the v value. So what we can do is we can take the time from 20 to 5 seconds and to 2.5 and subtract them to find the original time at v. So 20 subtract 5 subtract 2.5 will give us a total t value for v for will be 12.5. and to find the v value, what we'll do, we know that our final velocity was 24.5 here, and they said that it deaccelerated at constant rate of 3.9 meter per second. So what we can do is we can just subtract 24.5 by 3.9, and we can see that we find that that's 20.6. and then we know that the t here was 5 seconds, so just multiply it with 5. There you go, just multiply that by 5, and the product of that will be multiplied by 12.5 here. So this is our full equation, 30.625, adding 73.75 to that, and then adding 12.5 into 5, and the total will be 166.875 meters. That's the final value of the height of the point H above the ground. Or if you want to find to the nearest meter, you can just convert it to 167 or 1 decimal place, so that'll be 167 meters. And there you go, our C and D parts are done. 5 and 4 marks consist of 9 marks. Pretty helpful there, and thanks for watching guys. Stay tuned for more videos from this series.